Welcome to IDS KT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Studio microphone. Today, we're exploring one of the most disruptive forces in modern defense, 3D printing. What began as a tool for plastic prototypes is now enabling on-demand military manufacturing faster, stronger, smarter than ever before. Just a decade ago, 3D printing was best known for making toys and trinkets. It was slow, small scale, and more of a novelty than a necessity. But all that has changed. Thanks to major breakthroughs, additive manufacturing is now delivering battlefield-ready parts with aerospace-grade performance printed right when and where they're needed. So how did we get here? It started with speed. Traditional 3D printers worked layer by painstaking layer. But pioneers like Joseph D. Simon changed the game with continuous liquid interface production, or CLIP, a process that prints objects up to 100 times faster than before. At the University of Michigan, researchers took it even further, using dual light resin hardening to print complex structures in seconds instead of hours. But speed is just the beginning. Today's 3D printers can handle advanced materials, from carbon fiber reinforced plastics to heat-resistant metal superalloys. In the military space, these materials are essentially used to produce everything from jet engine parts and missile casings to drone frames and even armored vehicle panels. Enter BAAM, Big Area Additive Manufacturing. With BAAM systems, the US Navy and Army are printing full-scale components like submarine hull molds and UAV fuselages in days instead of months. Using thermoplastics blended with carbon fiber, these prints are tough, light, and ready for action. Metal 3D printing has also reached the front lines. Technologies like directed energy deposition and laser powder bed fusion now allow for precise, high-speed metal fabrication. That means mission-critical parts like those in fighter aircraft or hypersonic weapons can be made on-site, eliminating costly delays in the supply chain. And the intelligence behind printing is getting smarter too. Artificial intelligence and machine learning are now embedded in 3D printing systems. These adaptive platforms monitor sensor feedback in real time, adjusting printing parameters automatically to ensure structural integrity and zero defect. This isn't just automation, it's optimization in the field. So, what are the practical applications? For starters, on-demand weapons and spare parts. With forward-deployed mobile print labs, soldiers can now produce replacement components for tanks, aircraft, or communications gear right on the battlefield. Next, custom UAVs. Instead of waiting weeks for drone deliveries, troops can now print drones tailored for specific missions, whether it's surveillance, electronic warfare, or target acquisition. And 3D printed infrastructure is no longer science fiction. Military bases are now experimenting with concrete printing to build barracks, bunkers, and runways in record time. Looking forward, the future is even more ambitious. Imagine self-healing armor made from shape memory materials, or biologically inspired designs that adapt their structure mid-mission. The Pentagon sees additive manufacturing as a cornerstone of its next-generation strategy, where military units operate independently, print what they need, and complete missions with total agility. Of course, sustainability matters too. Recent advances like BlueSint PO12 allow printing with 100% recycled powder, drastically cutting waste without sacrificing quality. It's a win-win. More efficient, more ethical production. In the end, this is more than a manufacturing shift, it's a strategic revolution. 3D printing empowers militaries to respond faster, operate leaner, and innovate without limits. The battlefield is changing, And thanks to high-speed, high-performance 3D printing, so is the way we fight.